Okay, this time we're going to sketch the graph of a rational function. So we've got to really remember everything about this. We have a vertical asymptote where where you have this set equal to 0. So at x equals -2. All right, so if we're graphing this at -2, I have a vertical asymptote. And I have, when x is 0, y is 0. So we have a y-intercept of 0, 0. And a horizontal asymptote, we look at the degree. We have a 3x over an x, so we have y equals, they're the same, since they're the same degree, it's a over b, so that y would be 3 over 1 or 3. So at 3, I have a horizontal asymptote. So that tells me all I need to know for that part of the graph. And now we're going to take the first derivative. So part 2, that would be 3 times x plus 2 minus 3x times 1 over x plus 2 quantity squared. We set that equal to 0. So all we have is, let's see, this is 3x plus 6 minus 3x. So I have 6 over x plus 2 quantity squared equals 0. So that means that I don't have any critical points. So that means it's either always increasing or always decreasing. And if you look at the function, it'll always be positive. So this is always increasing. Okay, so I know it's always increasing. All right, so it also shows us that it's undefined at x equals -2, but we already knew that. So we have an asymptote there. Okay, looking at the second derivative, okay, we got, well, let's rewrite it. 6 over times x plus 2 to the -2. And we get y prime prime equals -12 times x plus 2 to the -3. So -12 over x plus 2 quantity cubed. Set that equal to 0. Again, it's always going to be, okay, now wait. Setting equal to 0, we have no points. Okay, we have no points that possible inflection, but we also have to do where it doesn't exist, and it doesn't exist at -2. And so let's see what happens left of -2 if I put -10 in there. So I would have a negative over a negative, and this would be a positive. So it's concave up before -2. And then if I put a 0 in there, I would get a negative over a positive, so that would be a negative. And so it's concave down after -2. Okay, and you know what these graphs look like, so the shape helps us know this is the regular. We would have to have a graph in concave up and increasing, so it's always increasing, and concave up would make it like this here. And it has to hug the asymptote, so you know it couldn't be here because that would be decreasing, right? So increasing has to be up high. And then this, if I put it in this corner, the other side, that would be decreasing. So I know it has to be in this one, and you can tell there it is concave down. So concave up over here and concave down over there. So that's how you graph that point. Now that's using calculus to sketch graphs.